Hello viewers and welcome. In today's lesson, we are going to look at temperature conversion. That is how to convert temperature from one scale onto another scale. In the world of science and mathematics, we have three scales on which we measure temperature. Now these scales are the Celsius scale, the Thermodynamic scale, and the Fahrenheit scale. Now these three scales are used extensively all over the world for the measurement of temperature. So our task today is to learn how to convert temperature from one of these scales onto another scale. All right. So these are the three temperature scales that we have: the Celsius scale, the Thermodynamic scale, and then the Fahrenheit scale. Now we have what we call the upper fixed point. So on the Celsius scale, we have the upper fixed point. We also have the lower fixed point. On the thermodynamic scale, we equally have the upper fixed point as well as the lower fixed point. And of course, on the Fahrenheit scale, we have the lower fixed point, and we equally have the upper fixed point, and we equally have the lower fixed point. All right. Now, between the upper fixed point and the lower fixed point is what we refer to as the fundamental interval. So the fundamental interval is the difference between the upper and lower fixed points. Now, the upper fixed point on the Celsius scale is 100 degrees Celsius. Its lower fixed point is 0 degrees Celsius. On the thermodynamic scale, the upper fixed point is 373.15 Kelvin. And its lower fixed point is 273.15 Kelvin. On the Fahrenheit scale, the upper fixed point is 212 degrees Fahrenheit, and its lower fixed point is 32 degrees Fahrenheit. All right, so these are the upper fixed points and the lower fixed points on the three temperature scales. Now, on the Celsius scale, the fundamental interval is 100. The difference between 100 and 0 is 100. On the thermodynamic scale, the fundamental interval is 100. The difference between 373.15 and 273.15 is 100. Now, on the Fahrenheit scale, the fundamental interval is 180 degrees Fahrenheit. The difference between 212 degrees Fahrenheit and 32 degrees Fahrenheit is 180 degrees Fahrenheit. So this is the fundamental interval on the Fahrenheit scale. All right. So moving forward, we want to use the thermodynamic scale and go down the temperature line until we arrive at 0 Kelvin. So to do that, let's start by going 100 below 273.15. If we go down 100 below 273.15, we will arrive at 173.15 Kelvin. All right. So the next step is to go another 100 below 173.15. And we are going to arrive at 73.15 Kelvin. And finally, let us go 73.15 Kelvin below 73.15 Kelvin. And we are going to arrive at 0 Kelvin. All right. So we are going to repeat this same procedure on the Celsius scale. So on the Celsius scale, let us go 100 below 0, and we are going to arrive at negative 100 degrees Celsius. So we go another 100 below negative 100, and we are going to arrive at negative 200 degrees Celsius. And then finally, let's go 73.15 below negative 200, and that is going to be negative 273.15 degrees Celsius. All right. Now, this temperature that we have here, 0 Kelvin, and its corresponding temperature here, negative 273.15 degrees Celsius. Now, this temperature is what we refer to as absolute zero. So equally, this temperature is also absolute zero. Now, what is absolute zero? Now, when the temperature begins to drop from 273.15, the temperature kept on dropping and dropping and dropping until it hit 0 Kelvin. Now, at this 0 Kelvin, the kinetic energies of the molecules in a substance are now 0. So the kinetic energy is 0. the molecules are completely static, absolutely no movement, and we say that the object doesn't contain heat. In reality, it's very difficult to get to such a temperature. Its corresponding value on the Celsius scale is negative 273.15 degrees Celsius. So this is absolute zero, and that is also absolute zero. Now 0 degrees Celsius is not absolute zero. We cannot refer to 0 degrees Celsius as absolute zero. The difference between 0 degrees Celsius and negative 273.15 degrees Celsius is massive. It's massive. So going forward, let's try to see how to convert a temperature. Let's take a temperature 40 degrees Celsius on the Celsius scale and try to find its corresponding temperature on the thermodynamic scale. Now how do you go about that? Now we are going to take that temperature and add to the lower fixed point on the thermodynamic scale, and we are going to arrive at the temperature that we are trying to solve for. So 40 degrees Celsius, we are going to add that to 273. So when we add that, we are going to get 313.15 Kelvin. So 40 degrees Celsius is equal to 313.15 Kelvin. Equally, when we have a temperature on the thermodynamic scale, assuming we have a temperature 330.15 Kelvin, and we are looking for its corresponding value on the Celsius scale, what do? What we are going to do is that we are going to take the lower fixed point on the thermodynamic scale and subtract from the temperature that has been provided, and we are going to arrive at its corresponding temperature on the Celsius scale. So to do that, we are going to subtract 273.15 from 330.15, and we are going to get a value 57 degrees Celsius. So 330.15 Kelvin is equal to 57 degrees Celsius. Now sometimes we do neglect the 0.15, the decimal. Sometimes we do neglect it in some books. So don't be surprised. You may be seeing temperature like 373 Kelvin without the 0.15, or you'll be seeing 273 without the 0.15. Yes, so that is that. So from here, let's give a simple formula that we can use. So if I have a temperature in degrees Celsius and I'm looking for the corresponding value in Kelvin, what I will do is that I will take the temperature provided in degrees Celsius, and then I'll add the lower fixed point of the thermodynamic scale, and then I'll get the temperature that I'm looking for on the thermodynamic scale in Kelvin. Equally, if I'm looking for a temperature in degrees Celsius, what do I have to do? I have to take the temperature that has been provided in Kelvin on the thermodynamic scale minus its lower fixed point, 273.15 Kelvin, and I'll arrive there. So with this in mind, coming from what we've just done over here, it will be easy to do our conversions. Now moving to the Fahrenheit scale. Now because the fundamental interval on the Fahrenheit scale is not 100 as compared to the other two, using this methodology is not going to work. So we are going to use a different approach. So let us use a fractional change. So fractional change on one scale should be equal to the fractional change on the other scale. So starting, now we are going to convert from the Celsius scale to the Fahrenheit. All right, so we are going to convert this negative 200, negative 200, and negative 273.15. All right, negative 273.15. So that's what we are going to do now. So we start with negative 100. So I have negative 100 minus the lower fixed point. The lower fixed point is 0, so there is no need I bring it. All over the fundamental interval, which is equally 100, is equal to the temperature that I'm trying to solve for, okay, here, which is y. That's what I'm trying to solve for. So y minus the lower fixed point on the Fahrenheit scale, which is 32, all over the fundamental interval on the Fahrenheit scale, which is 180. So I have this. So I now group my like terms together. So my y now becomes negative 148 degrees Fahrenheit. So this is my temperature. So negative 140 degrees Fahrenheit is my temperature on the Fahrenheit scale. That corresponds to negative 100 on the Celsius scale. All right. So we use a fractional change formula, and when we use a fractional change formula, it becomes a way for us to be able to find the corresponding temperature on the Fahrenheit scale that matches with 100 degrees Celsius on the Celsius scale. So let us do for negative 200 and see what we have. So I have negative 200 all over 100. This is equal to y minus 32 all over fundamental interval of 180. So what do I have now? So I have 100 y minus 32. This equals negative 200 times 180. So I have this. All right. So I'll group my like terms together. And that gives me my y. Okay, so with this simple gymnastics again, I have negative 328. So negative 328 degrees Fahrenheit. So negative 328 degrees Fahrenheit corresponds to negative 200 degrees Celsius. All right. So here I have negative 148 degrees Fahrenheit. Here I have negative 328 degrees Fahrenheit. And finally, let's see what we have here. So with the same method. So here I have negative 273.15 all over 100 equals y minus 32 all over 180, right? Okay. All right. So from here, okay, so I group my like terms, and what do I have? All right. All right, so my multiplication, addition, and then division, what do I have? Negative 459.67 degrees Fahrenheit. So here I have negative 459.67 degrees Fahrenheit. All right, so after our conversions, negative 100 degrees Celsius equals negative 148 degrees Fahrenheit. Negative 200 degrees Celsius equals negative 328 degrees Fahrenheit, and negative 273.15 degrees Celsius equals negative 459.67 degrees Fahrenheit. So using the fractional change formula, we are able to convert from the Celsius scale onto the Fahrenheit scale. Equally, we can use the same method to convert from the thermodynamic scale onto the Fahrenheit scale. So this is how we go about that. Converting from Celsius scale to thermodynamic scale, because the fundamental intervals are the same, it's pretty much easier. We can quickly do that. Now when we move to the Fahrenheit scale, the fundamental interval is different from the other two. So to do that, we use the fractional change, and then we go about that with our addition, multiplication, division, and then we can arrive at the temperatures that we're looking for. So with this as a foundation, we should be able to convert any temperature at all from any scale to another scale. Any of the scales that is provided, we should be able to convert that temperature to the other scale that we are required to. So with this, I think we've come to the end of this lesson. That is lesson 1 on temperature conversion. So in our next lesson, what we'll try to do is to go and then try some different examples. We'll try some different examples and then try to even further enhance our understanding of the temperature conversion. All right, so this brings us to the end of this lesson. I've enjoyed the lesson. I hope you have also enjoyed the lesson. Until I see you next time, remember, as always, take care of yourselves and each other. Bye.